Good morning. Today we are live coding again, and the topic is closer integration between Nix on the back end and Pharaoh Smalltalk on the front end in our Studio development tools. So in the last sessions, we've done a lot of work on making Studio easier to install. We realized that actually there were a lot of problems we weren't conscious of before, and we did a lot of fixes, and we set up continuous integration, and we put everything into a much nicer state. And now what we want to do is look at the user experience after you successfully install it. The next thing that you kind of are going to stumble on is understanding the operation. So we're going to give that a little bit of love today. That's our idea. I made a little to-do list to keep track of the kind of our stack, and some specific things that I want to do. First, I want to make it possible to use the UI to search the Nix software collection to see what software we have available. Like, we've done a lot of examples running RaptorJIT, which is very nice, but RaptorJIT is just one of thousands of kind of bits of software that Nix can address, and they're all kind of addressable within Studio, so we want to make that more visible. We also want to be able to see what happens when you run a build. So again, when we run a RaptorJIT program, a lot of our examples have been things that run pretty quickly. So it maybe takes 10 seconds or something to run a little small benchmark and give some results. But generally, when you run a Nix expression, it can take an arbitrarily long time because, for example, we could enter an expression that asks us to run a RaptorJIT test with a RaptorJIT VM that was built using a specially patched version of GCC. And maybe we want to look at this new retpoline support or something like that. So we could actually write that in the Studio GUI. We could specify the software build environment even to apply patches to basic software like libc and GCC and that kind of thing. And if we would do that, it might take actually quite a long time to get our result because it might trigger a lot of builds depending on how much software we want recompiled in a different way. And we want to have some visibility on that. So when we enter something in the Studio user interface and ask it to build, we want to see the progress, basically. We want something like a progress bar, so we know it's not stuck, we know that it's going forward. And we also want to be able to see errors. So if something goes wrong, we don't really want to get the small... If we have an error in our Nix code, we don't want to get a Smalltalk debugger and have to fish through and kind of find the output from the Nix process. We want to get the actual error. So these are the things that I'd like to look at today. For each one of these, I've noticed when we do these live coding sessions, often there's a few different ways we can attack a problem. We usually pick, maybe there's 3 different ways, and we pick the one that seems most promising, and we start going on that. And if we hit some obstacles there that were not expected, we sometimes go back to another approach and try that for a while, and then if that is also a problem, we might switch back. And I reflected that this is the A* search algorithm. It's a well-known search algorithm called A* search, where you know where you want to get to, and you know what paths you have available, and you've gone a certain distance down each of those paths, and you kind of estimate, given how far you've already gone down each path, which one is likely to get you where you want to go with the least additional effort. So when you follow one path that looks promising and then it starts turning in the wrong direction, at a certain point you say, well, now actually it seems more promising to try this one, and then if that goes in a funny direction, you balance them out. So we're not doing a depth-first search of these problems where you can kind of go infinitely far down a hole and never get anywhere. We're also not doing a breadth-first search where you do everything in parallel and you always find the shortest path, but it can take you a long time. We're doing an A* search, so I'm not going to feel bad about hopping between different technical approaches. I'm just applying computer science to the problem. So let's get started. So the first one, being able to search Nix packages with the spotter, which is a search engine built into the Smalltalk image. I'm going to pull that up and show it now. And this is something I've actually prototyped a long time ago. I think it was the very first thing I ever did with Studio was to prototype this to get a feel for the Smalltalk tools and interacting with Nix from there. So I need to find that code and see if it works, and I'm sure it's not perfect, and make it something that we can actually kind of really adopt as part of the software and use and explain. So let us start Studio somewhere. This is I'm on a Mac. I have a terminal here on a Mac. It's connected to a Linux machine. I start Studio in VNC mode. It makes sure that it's built all the latest versions of all the dependencies, and we get a VNC desktop on display 28. Pop over here and run a VNC viewer on the Mac so that we can get a graphical view. So here we have the Studio GUI. So this is a Faro Smalltalk environment actually, and during initialization, it's actually just created a full screen window. So if I would press Control W, then that window would get closed, and then we would actually see the standard Smalltalk menu desktop, and we can click to get a menu, and we can go through and do all the normal things you can do there. So at some point we're going to hide this a bit better, and make it a toggle whether you want to see the Smalltalk universe visible or not. You want it if you're developing on the Studio front end. You don't want it if you're just trying to use it. It would just be a distraction. But the thing we want to look at now is something called the spotter. I'll just give you a quick demo of the spotter. And this is developed by, as I understand it, a group at the University of Bern in Switzerland, which is really close to here. I'm in the Berner Oberland. It's a really cool search engine. So if I press Shift and return, then this window pops up. This is the spotter for searching, and I can type a substring here for something I'm interested in. So what are we going to look at? Suppose we're interested in something in the Smalltalk image. We're interested in things that relate to strings, shall we say. If we type string here, what do we get? Well, it says there are some classes that have string in the name. There are 48 of them. And here is the first 5. And there are also packages that have string in the name. Well, there's one, and here it is. And if we scroll down, we see that there are implemented methods that have string in the name. There are 1,600 of those, and here are 5 of them. There are places where methods are called, messages are sent with string in the name. We have code that we've entered interactively somewhere that has that in the name. We have help topics that relate to strings. Okay, so those are the things we have. So the interesting thing now is we could filter this to pick one of these areas, and we can also do there's 3 things we can do. One is that we can filter. Like if we press Control B, we're just going to see classes, and it's going to take away the packages and everything. We have this preview button we can press. If I press the preview, then I can get more information about the thing here. So there's a class called string, and here we see some information, a preview of that class. It says, it's a subclass of arrayed collection. We can take a preview of the strings package. We see some of the classes in that package. We can take a preview of an implementation of a method, a string method. We can take a preview of something that sends the string method. So that's a method that calls a function or sends a message with string in the name. Anyway, so yeah, we can filter here. We can see a preview here. And the other thing we can do is what they call dive in. And diving in is where you make a recursive search within the results. So what do we have here? We had something we had a lot of was implementers, right? So there's like 1,600 method implementations that have string in the name. So if we would click this button, then we dive in and we can do a recursive search amongst those. So now we can type a new, we see our search stack here. So we started off in the main spotter, and then we got some results, and then we recursed into implementers of methods with string in the name, and we got we get a lot of methods here now. And so if we would write a substring here, like we're interested in regex, for example, okay, now we see method implementations that have regex in the name, and also have string in the name, because that's what we searched for before. Anyway, so the thing about this search engine is that it's extensible to everything. So the idea well, the specific idea here is that if we type something here, we should also be able to type a fragment of a Nix package, a software package, and we should be able to see if that's packaged for Nix, what its exact name is to reference in a Nix expression, what version it is, and that kind of thing. And I'm actually going to try that to see if it works, because I have prototyped that at some point, and it might or might not be in this. It might not. The code might or might not be loaded now. I don't remember. It's like a year ago or something. If I write GCC, what happens? Okay, we don't see anything Nix, so it doesn't look like we got the code. We see some method implementations that have GCC in the name. Okay. So we're going to have to find that code or write it again. I'll try one more just to be doubly sure. If we write Wireshark. No, okay. So what we want to do is get searching enabled for nix expressions. If I write Wireshark, I want to see the packaging of Wireshark has been made for nix. I want to see what version it is. I want to see a description of what the package is, who maintains it, that kind of thing. The basic metadata. And I can show you how that looks on the command line as well. On the command line, we would write, for example, nox to search nix packages for Wireshark, and it would think for a while. And actually, I would also like to avoid this thinking because with Studio we've got all of the software pinned, so we should actually be able to efficiently kind of pre-compute all of the available packages. But when I run this on the command line, it looks both on the nix unstable release and on the nix stable release, and it tells me I have 2 different versions of Wireshark available with 3 different builds: a Qt, a command line, and a GTK version. So and there's more information than that available as well that we want to show on the GUI. So right now we're looking for code that could be anywhere. I was hoping it would already be there. And let's have a little bit of a closer look. So we can see that the code is not enabled. Is it actually lurking here somewhere? That would be handy. If we look for nix, we want to package Studio nix. This is code in Studio for dealing with nix. Is there anything here? Nix packages. Okay, so maybe the code is there, but it's not initialized. And I've been a bit sloppy with writing comments for the Smalltalk code so far. That's something we're going to do on another session, actually, is go through the Smalltalk code and properly comment it and assign all of the methods to the categories and that kind of thing. I've been charging through a bit hack and slash there. But anyway, I think that this looks like relevant code. Yeah, spotter preview. But I think the code is there. I think maybe we just haven't loaded the package definition. So when we did the search, maybe it did actually look for a nix package, but it wasn't aware that any existed. Nix packages default. What would happen if we open a workspace and we run nix packages, nix packages default. So we want to get an object that represents the default nix packages collection. Seems to be the way that I wrote the code originally. If I run that, Control G, okay, we get a nix packages, and it is apparently empty. Okay, so we want to populate that somehow. So what methods do we have? Scan packages. Okay, so we run scan on that. Self-scan. Would not run nixenv. Do we not? It is wrong. Trying to run a command line program nixenv. Okay, and I've got a really nasty hard-coded path. So I did warn us that this was prototype code. So it's hard-coded for some machine, not this one. Like I wrote this on a Mac. So if we would just do that, would that be a reasonable starting point? Try again. We've asked it to scan. Seems to be busy. Hopefully it's doing something productive. So I think what the scan does is it goes out to nix on the command line and it says, please dump a list of every package in the whole, every addressable package that nix knows about as JSON. And then we parse the JSON in the Smalltalk side, and then we kind of have objects. Okay, so now we have this nix packages and ordered collection. Okay, so now we have an ordered collection of 26,000 objects of type class nix package. Okay, and it's searching both the unstable and the stable. So this has gone off and looked in the same package collection that we've got on the command line, which is fine for just right now, but it's not actually what we want. We want to specifically search the packages that Studio would use, which is a very specific pinned version. So it's not actually looking in the right nix packages collection. But let's have a look here. So there's some Where is some package that should have good metadata? Where's something very popular? Oh, where's something random? It's metadata. Okay, I'm gonna try doing the search again now and see if something shows up, because that would be really cool. So if we try searching for GCC, what happens? No. Okay. Now, I was hopeful there. If we search for GCC, we don't see it. What if I search for Perl? No. Alright, so we got some packages there, but somehow the search integration is not working. Okay, fine. So let's go back to where we were. nixpkgs default. We have. Now, when we ask for the default Nix packages, we get Nix packages object. It has an instance variable called Nix packages, which is an ordered collection, which is more or less to say an array, 26,000 packages. Okay, but the search didn't go in there, so let's see why not. How does this ask that object to browse its own code? Okay, so it just does a scan and everything. So this Nix package object, we have a preview method. You remember on the spot, if I call it the spotter again briefly, preview is this thing that we have here. So we have some code that's supposed to present metadata about a package in the preview here, but where is the code for actually tying into the search so that when we type something here, it will look for Nix packages. And this is the only time I've ever done an extension for the spotter, so I don't really remember how the API works and all that kind of thing, and it's entirely possible that I just kind of missed checking in that code or something, because I haven't looked at this in a long time. Okay, so I think we gotta look on the internet at the glamorous. So the spotter comes from a package collection called the Glamorous toolkit, which is really cool. I mean, so the whole idea of using Pharo Smalltalk for the front end was basically to get access to this very, very, very nice toolkit. Well, both Glamorous toolkit, which is the spotter and the inspector and these things, and also this other thing called the Agile Visualization toolkit, which is what gives us graphics, directed graphs and that kind of stuff. So these are really, really, really nice packages. And the reason to do the UI in Smalltalk, as I say, was to participate in these communities, because I think that these people have taken a very good approach to the problem that we're interested in. So it's better to cooperate with them rather than cook something up from scratch. So the spotter. How do you extend the spotter? Discovering and managing Glamorous Toolkit spotter extensions. That sounds promising. GTSpotter is moldable. So moldable is this keyword that they have for meaning that you can adapt it to different applications. So they say their tools are moldable in the sense that we're interested in looking at like Nix, and they can be molded to the shape of Nix, and we're interested in Rapligit, they can be molded to the shape of Rapligit, so that they can look at packages and whatever, that they're quite adaptable. And there are 120 in Pharo 5, which is old. We're using Pharo 6, and Pharo 7 is on the way out. So in that one, they had 122 different kinds of searches, so classes and methods and everything. There are 122 little bits of code in the image, at least because that's an older version, that try to take a string and figure out something to do with it. So we're adding the 123rd one when we search for Nix packages. And what do we have? That's too small to read. When you look for live examples, you can inspect GCSpotter and you will get a list of all the extensions. So have a look at that. I'm inspecting the class GTSpotter, and it looks like they have this inspector also is one of their tools. So you inspect an object, it pops up, and you have the opportunity to write plugins that add tabs here. So that's also what we're doing in the studio. We want to look at a log file, for example, and maybe we have one that shows it as raw text, and then we add another one that visualizes it as a graph. We have another one that does a special textual one, whatever. That's the basic model here. So extensions. Here are all of the extensions that exist for the spotter. Is there anything about Nix here? Okay, no, it's not all, that's the first 50. So we might actually want to search for these, mightn't we? Let's use the spotter to look for spotter extensions. We might look for method implementations with the name spotter in them. There are 200 of those. Are there any with Nix in the name? Yes. Okay, that's the spotter preview. All right, so that one we already knew about. So we have the spotter preview, but we don't have the spotter, Nix packages for. So we want to add something here. Oh, we can search there as well. That's nice. Okay, so seems like in order to make the spotter search for a new kind of thing, we need to write a method like this. We will write like spotter Nix packages for a searching step, and we will use this special pragma that somehow allows the spotter to discover our method. I guess we're going to put a method like this on the Nix packages class, right? Let's just pull that up. We already have it here. And this is presumably something I've written at some time, but don't have anymore. So we'll just write it again now. Also a little bit of space. We're going to have a method called spotter Nix packages for a search step. What are we going to give this? I guess we'll give this a relatively high order, and that's, at least for now, let's give it a high order because we want to see it when it pops up while we're debugging anyway. Later we can think about what is the most appropriate. And what are we going to say? I'm just cargo culting this right now. I should note at this point that there is a book called Moldable Tools. So a clever fellow did his PhD on this Moldable Tools concept fairly recently, I think last year, and this is actually a really good document. This actually goes into, it explains what the big idea is, it gives examples, and it also shows in detail how to make extension methods. So all of the information that I'm stumbling around blindly cargo culting, this is actually in here. And I actually have a hard copy of this, which is not as good as the electronic copy, so I don't recommend buying that from Lulu. But anyway, if I wasn't live coding, I might go and sit down with a cup of tea and read this more carefully. I'll do that later. But at the moment, we're just going to try to get through it. But anyway, this is actually a very well documented library, and it's just for the sake of our own entertainment that we're not stopping and rereading the manual, because I read it quite some time ago. Anyway, I digress. Item. I don't have a key binding yet for doing Nix search engine. What do you reckon? Any chance that did something? Let's see. Now we have a method that has a filter object that takes 2 arguments, a filter and a context, and it gets the list of all Nix packages, and it that applies the filter to each one of the packages. So we're hoping that is kind of doing what we wanted to do. We'll find out. We'll see what happens. And I'm going to press Shift and Return to pull up this again, and I just remembered that there's some other key combination that's for the debug mode. We might have to dig out what that is. So if you do Shift Return, this is user mode. If there's an error, it will just kind of silently ignore, whereas we'd probably like to see something pop up. Anyway, let's type GCC. Nothing. Okay, let's try and run this in the debug mode then. I'm going to guess that it's Control Shift Return. Did nothing. I'm going to guess that it's Command Shift Return. Which, Spotter in debug mode. Nice. Okay, so what about if we type GCC now? Okay, we still get nothing. So, did that extension show up? If we go in and look for Spotter extensions again, inspect the GCC Spotter class, then is this going to show up? Did we do the right incantation here? Get the naming right? Is the Spotter aware that exists? I don't know if we need to kick the Spotter if it's cached things as well. I don't know. Do we see anything with Nix here now? Yes. Well, that's nice. Okay. So it has detected that our extension exists. I want to be able to compare our one with another one. We returned an object. I don't know if that's relevant. We turned the value of this, the other one didn't. They just executed for side effects. Probably doesn't matter, although we don't actually want to be different there, so we will go back as it was. Right code here. I click that, accept. Alright, hopefully it worked. I quite like this about the environment actually, that here we found some source code fragment in a search engine and we were able to edit it and say accept, and then it actually gets loaded back in and running. So this is kind of it's actually really nice. But back to the problem. Well, hang on. Which object is this running on? Nix packages. A method on the Nix packages object. So do we have a Nix? Is there a Nix packages object? Is there an instance anyway? Nix packages all instance. Yes, we do have one. Does it have any packages? Yes. Okay. I'm just a little suspicious about how it's finding. It's finding an object to run that on. I mean let's have a look at that web page again, because I mean it seems like there's 3 steps when we do a search, right? We needed to find an object that represents the Nix packages collection. I got no idea whether that's happening at all now. If so, and if it is, then how? Then it needs to ask that object to do a search, to take a string, filter string, and say which packages match that. That's the code that we wrote here. And then we want to be able to get a preview of the individual objects, and that's code that we all saw already exists in somewhere. So the first object that gets rendered is the GTSpotter. Kind of runs itself and it will somehow find objects. Yeah, things can be enabled and disabled by settings, so it might be worth checking first whether we are enabled or disabled, whether we have anything there. Settings. Okay, we do have a setting, and we're enabled. Okay, that's nice to see anyway. And this is where we can selectively enable and disable things. So this will be relevant for Studio when we have like a user mode versus a developer mode. When you do a search from a Studio user perspective, you're not really going to want to see any of the Smalltalk stuff. So we'll disable all of that by default and have a way to enable it when you're actually developing the UI. But anyway, that exists. What about if we would set a breakpoint in there? That seems like a reasonable thing to do, doesn't it? I want to put a breakpoint here. And I also want to put a breakpoint here. Each time we look at a potential package. Oh well, no, here. Put a breakpoint there. Okay. Now, if we run the search engine in debug mode, like this. We're at GCC. At least now, I guess we see clearly that code's not running. So the problem is, method doesn't run, even though it is detected as a spotter extension method. Okay, so let's have a look at this GTSpotter object and see what how does it find objects that are inspectable? We wanted to find our nixpkgs collection. How does it do that? Does it need... Oh, okay, so maybe this is where we need to put that method actually. So we put our method for searching nix collections on the nixpkgs object, but maybe that was the wrong place. That's maybe for when you are... I mean, we're searching at the top level, so we open up the search engine and we write GCC. We're doing a top-level search here, and if I understand correctly, the top-level search is searching in this GTSpotter object. So that's where our method should actually be, I think. So we want to actually move this method to another class. I wonder if you can... What do you think? Can the refactoring tools do that? Move. That means classes to move. No, we want to move a method. Let's take away our breakpoints. We might need them later. Away for now. I'm an Emacs guy, so I normally, don't use refactoring tools, but another world. So let's have a look. I think the move is talking about moving a class to another package, not a method. Okay, but we'll do it the old-fashioned way, right? We make a copy there, and we hop over here, and we put it there. Fine, now we have that. And over here, we will delete that because that's not the one we want anymore. And let's see what happens. Now we have that method on the GTSpotter object, and we write GCC. Okay, that didn't get anything again. So let's put in our breakpoints again, and let's run that in debug mode. Well, actually, let's run in debug mode first without breakpoints, in case there was an error. Ah, yes. Ah, okay. We need to get the nixpkgs collection, but of course this GTSpotter object doesn't have access to that. So, not self packages, rather it's nixpkgs default, I believe. Let's check that. If we write nixpkgs to default, what do we get? Get the nixpkgs, oh, and then do we have to say packages to get the individual packages out of that? Yes, okay. So when we do a search, this is something we want to change for Studio. We want to actually search very, very specifically the Nix packages collection that Studio would use with all of our pinned versions, but we're not on that step yet. What happens now? If we run that, debug mode, GCC. Ah! That's becoming a bit more cool, right? So we wrote GCC in the search engine, and let's close. That's okay. So we're seeing Nix packages here. We see that in the Nix, we see that there is a Nix package in the Nix source unstable distribution called GCC 7. We see some information about it here. If we want more, we can say yes, that's the object we're looking for. Then we can get the method out of there and go in a bit closer. See all the platforms it supports, okay. But that's cool. So here we are again, the search engine. Now we write the name of a package, and let's say Perl. Well, Perl is nice too, right? So we say Perl. We see the value of this spotter here. So we wrote Perl. We got a Smalltalk class that had Perl in the name. We got some Smalltalk methods that had Perl in the name as well. What we care about is actually just Nix packages. So if we do this dive in there, then that is doing a recursive search now on just Nix packages. So now we're doing a recursive search on just Nix packages that have Perl in the name, which is actually kind of relevant, right? Because there's zillions of them. So so what do we want to say? If we're going to do something with XML and Perl, there's an awful lot of those too. Well, okay, that's cool. Then we can do another step of recursion there. We've got 50 packages that have Perl in the name and have XML in the name. We go in there, yeah, if we're interested in Perl, XMLRPC, then we go down here. So that's actually a pretty interesting use case for me. Often when I do a search for a package, if it is something fairly generic I'm looking for, like XML or something like that, I get a tremendously long list of packages, and it's not always obvious how to effectively filter those search results down. So that's a problem that's just solved for us. With this spotter in the Smalltalk environment, the searches are recursive and they can search all kinds of objects. So that's very good. And actually this is, so if we wanted to, well, it's not searching our collection, right? So we can't get Raptorjit there. There's no Luigi package there either. Is there anything for Lua package at all? Oh no, sorry, I'm still in this recursion. How do we break out of there? And go back up to the top level. All right, Lua. What Lua is packaged for Nix? We have Lua 5.3. Have a bunch of individual packages, 5.2. So I don't know. This is pretty cool. This is probably the way that I would actually look for Nix packages. So what's wrong that we should improve? One thing, obviously, is that this is a bit of a boast, right? We don't want to see this a Nix package. We just want to see the name of the package. That's something that we should improve there. And the other thing is that when we search here, it's finding the packages for whatever random Nix installation is on this computer, and that's not what we want. We want to search specifically the package collection that Studio addresses, which is a pinned version of the packages. So we're going to do those two things. We might take a 5-minute break and then do those two things. Yeah, we are back in 5 minutes to do that. Cool. back we hop. We were right in the middle of putting search support in for searching Nix packages from the Vero Smalltalk UI. So where we've gotten to is that we pop up the search engine and we write Perl, and one of the things it offers us is a list of Nix packages. And the next thing that we want to do is fix these names. So it means we just need to find the appropriate method for formatting those names, and to do that it would be nice to find an example. So if we see what else, so classes, for example, are formatted without saying a class something, it just says the name. So why don't we look for how that is done? So we have the GCC spotter, or GTSpotter. Object itself. So I use the search engine to find the search engine. Pull that up. We want to inspect that, don't we? So we will use the inspector on the search engine. And we had a list of extensions and class. Okay, class. How do we actually find a list of classes? Ah, no, okay. This is all the different objects that can be searched inside recursively. So this is an interesting thing. We've only really scratched the surface with the spotter, because it can actually go in and do searches on individual things. So we could do a search on a Nix package, for example, and it could then recurse in and search the dependencies of that Nix package or whatever. We're not at that level of ambition right now, but that's what we're seeing here, is all these objects where you can actually search inside objects. And we're only really interested in the top level searching for a package. So I'm in the wrong place there. We want to actually read the code for the GTSpotter, and we want to see its spotter extensions. Classes. Okay, so here is where it makes a list of classes. So because somehow it gets nicer names than we do. The code is also a little bit easier than ours. They said filter GT filter substring. We're going to see if we can do that as well, because we had, I don't remember what we had exactly, but it was longer than that. Where are our packages? Maybe we'll come back. It looks like we could probably refactor this to be a little bit more simple. But anyway, I didn't see anything. Oh, excuse me for just a moment. That's under control. So if we go back to where we were, where it gets the list of classes. So code to neatly format the name of a class is conspicuous in its absence. I don't see anything there. So maybe it's the class object itself that has a method for saying how it wants to be printed. So let's check for that. If we look, we search for a class called class, which is here, and we'll open that. And we'll see if it has any spotter extension method. Yes. Although nothing obviously ways to do all kinds of previews, although nothing I see there that has a name. Yeah, let's look for another example instead. I'm not sure how well. Let's just check if we get a class like the class and we print it. Ah, okay. I'm sorry. it was a bad example. So actually, if you take a class like nixpkgs and print it, it actually does always print that way. So actually, the search engine is not doing anything clever. If you ask a class object to print itself, it'll just give you a neat name. So maybe we should just do that with our nix packages. Actually, it's a bit gratuitous to be always printing this long thing. So let's do that. If we make nix packages just print their own names a little bit more nicely, I think. So nix package is what we want. We already have a print on method. Actually, that kind of ugly verbose thing is something that we were kind of doing, that we're doing manually here. We have a method to print on a stream. We do the super class print on method, which will do this a nix package, and then we print the actual name of the package in parentheses. Let's just streamline that. I think it's the right thing to do. We just say, when we want to print on a stream, we say a stream print the attribute path, and we're done. Could that possibly work? Now we do a search for Perl. Almost, right? So it's still in quotes there. So let's do this instead. Let's just print all the characters of the attribute path. That looks a bit better. So we see you could this is showing what you could write in a nix expression to reference a dependency, and that's what we want basically. So if there's a package that we want to use in a nix expression in Studio, we want to just type a little bit of the name, like XML, and we want to see all the packages available. And we say, okay, the Perl package RPC XML is the one that we're interested in. It has this name with this, capitalization and everything. So that would actually be very useful to be able to quickly pull that up. This is done and nice, and happy about that. So we're going to say that is done, and now we want to search in the relevant package collection. So again, this is searching in just whatever this computer happens to have as the default nix collections. That has the stable branch and the unstable branch, but we actually want to search just for packages that are addressed by Studio, which is this very specific pinned version. So where do we get the package collection from today? We browse that code again. We will search for nix. So I do everything through the search engine now. Absolutely everything, anything I want to find. I want to see examples of how a code is written. I just write a fragment of what I want to see in the example. I put it here and I search it. So this is actually such a good search engine that after using it for just a couple of hours, I started getting really frustrated using Google. I used to think that Google actually was a very good search engine, but now it makes me crazy on Google when I can't do recursive searches. I can't. Maybe it is possible, but I'm so used to just. I very quickly adapted to this spotter search interface. So for me, it very quickly became the way searching should be done. So I'm very enthusiastic actually about extending this in a lot of relevant ways to search for stuff that I care about. Continuous integration results and nix packages and git commits and God knows what. The future looks bright for searching for things. Anyway, right now we want to search for a package of Smalltalk objects as nix that has Studio in the name. And now we see nix packages that have Studio in the name too. Cool. And we put this at a fairly high priority 10. Might be a bit high. It comes above the Smalltalk packages, but anyway, that's another thing. But it's cool. So this is just totally integrated now. Anytime you search for something, if you don't say what it is you're searching for, then it will include up to 5 matching nix packages in case that's what you wanted. We wanted package UNIX, and we want to see when we scan the nix packages collection, scan into JSON array. So this is the command that runs to get a JSON representation of the nix packages collection, and we what do we want to do instead? We actually want to do something a little bit more nixy, you might say. We want to build a JSON text file, and it's going to have two dependencies. One is going to be nix, and the other is going to be one specific version of the nix packages collection. And this is going to be really nice, actually, because that's going to be, those dependencies are going to be tracked, and it's going to be cached in a very effective way. So we're going to build this kind of just once each time we actually change the package definition. So we'll always, we won't have to, like when I first started this image, the package collection wasn't there. We had to actually run this command to build it. It took, I don't know if it took 5 or 10 seconds or something, but we're going to be able to get all of the JSON data cached automatically by nix, I think, when we do this. Okay, so now we're going to do a little bit of nix hacking to build the package collection. And in principle, after we've done this work, it might be that we do our nix hacking directly in Studio in the near future, where we would say like Studio Inspector kabunk. I mean, we do have an area here where we can type a nix expression and get it built. And what we want to do now is actually to improve this setup so that we get more visibility, we have nice debugging support and that kind of thing. So at the moment, this is a bit of an impoverished environment. It's not as nice to work in as the command line and Emacs. I think that situation is likely to change quite quickly. It would not take very much nice kind of debugging and testing tooling here to overtake that, I think. So that's anyway, that's an exciting possibility to me. But for now, we're going to hop back over here and do this in Emacs. So let's might just write this in a file. So I'm just thinking about where we're going to put this. Is this package collection logically a part of the user interface, for example, or what is it? We'll think about that later. For now, we have a file called nix/packages, which returns package list as nix objects. And I think what we want to do now is make packages JSON that does kind of the same thing, but as JSON. So let's just see our other stuff that we do is we just write this from scratch. We say with port, that imports the package collection and puts all of the package names in scope. So when we write, if we write GCC now, that's going to refer to a version of GCC loaded from that package collection. And what we're going to want to do now is run a command called I want to have nix available when we run that, because this is a nix expression that is going to run nix because it needs to query the package collection. Now we're going to reference the packages collection exactly. So inside here, we're presumably going to run that same command we were running before, but in a different environment. So what was that command? That. Take that. Multi-line string. So when we run the next end, we want to run a specific packages selection. I wonder if this is going to be allowed, if we can say that we want it from what I'm hoping there is it will evaluate this packages.nix by going off and downloading this tarball and unpacking it. I think the fetch tarball unpacks it. Okay, no, but that doesn't import. We don't want to do an import. We actually want this. And now we might just take that and we'll refactor it if it works. Emacs copy paste error there. So there we have. You can fetch a tarball containing the definition of the next packages. I think, if I'm remembering correctly, the fetch tarball is going to unpack that. So this is going to evaluate, well, it might not matter in this case anyway, but it's going to evaluate to a directory. Then we're going to run nixend. I think -f tells it to load the package definitions from this directory. And then print JSON with metadata, description, derivation path, attribute path, a query of all packages. This is worth a try. What's the worst that could happen? Like this. Nix build. Unexpected semicolon, expecting end, line 8. Find out if there's a semicolon there. Download the tarball, which is nice. Actually, it's funny, it's downloading the tarball because this tarball is actually invariant. I know that the tarball is invariant, but Nix doesn't know that it's invariant. I haven't told it. So somewhere we should actually be able to provide a SHA-256 hash for that tarball, and then we would only ever download it once actually, because we would say we want to get value at this URL and we want to verify it has this hash, and then locally Nix will be able to say, well, we already have something with that hash from that URL, so we don't have to download it. Anyway, value is a function while a set was expected. The hardest thing that I find about Nix is type errors. Nix is a lazy functional language, not statically typed, and for me, not being statically typed is a feature. I'm very happy about that actually. But when there's a type error, I want to see the runtime values. I sometimes have a hard time guessing. I just want to see the value pre-printed. It says value is a function while a set was expected. So what did the function look like? What function was it? Anyway. We will ask it to show a trace. See if that helps in any way. It has to go here. Did I say it? Yes, I did. Okay, so no trace was available. Value is a function while a set was expected. So Nix is a lazy functional language. It's also curried if you're into functional languages, So run command should take 3 arguments. If I would give it accidentally 2 arguments, then to represent having too few arguments, it would actually return a function that wants another argument. So one way that I would see an error like that would be to provide too few arguments. But I think that's correct. I think run command wants a package name and a set of attributes describing how the build environment should be, and then a string saying with the command that should be run. And here we reference this Nix packages, but that should not be expecting a set. So, come on, I would like to have a line number. Can I really not get a line number here where the error occurred? Nope. Hang on. We do have kind of, we're running nix recursively here. Maybe I'm tracing the wrong one. Maybe that didn't help either. Just keep track of where the heck we are. Because it was not running in there. This is something that happened earlier, but it downloaded that, but it might have been downloading that for this purpose. How do you do printf debugging in lazy functional language? We'll try just shortening this to just what about if we would just return GCC? Does it get that far? No. I think we might, when we import the packages, we might have to say that to load it correctly. I always fall for that. Cool. So what's happening now? It should be downloading everything that it needs. We just look at this output a bit. Failed. Creating directory var nix, permission denied. So we're trying to run a kind of recursive nix inside a build sandbox, and I don't know if you're allowed to do that. So the nix build environment where this command runs is quite a sandbox. It's a cheroot. It's very kind of tucked away from everything. I don't know if you can run nix inside a nix sandbox, but I'm sure someone will have asked that before. Can you run nix inside a nix sandbox? No? Have they not? Recursive nix. issue number, wow, issue number 13, that's a long time. Okay. Hang on, we were running nix end. Maybe nix build is what we wanted. Hold on. Because nix end might be trying to install stuff. Let me just briefly try. No, hang on, nix env is what we want, because we want to get the JSON package format. Okay. Five-year-old discussion. This is referenced from a newer issue. Let's paste that reference. Here's a PR. Got to run nix within a nix build. Did this go in? In 2017, a year ago, there was an attempt to resurrect this. Here's somebody possibly trying to do something similar to what we were doing. Port from derivation sounds like something that we need to know what that is. I'm going to chase that link back where that number. And what was the conclusion of all this? Were people happy or sad? Here is a superseding request. Again, what we're trying to do here is run nix inside nix, right? We want to do a nix build that runs nix to query the available packages and writes those to a file. And we're just getting an error that within the sandbox we don't have a nix store. Do people end up happy with this? Promising. Integrated with master. What does this code look like? We're looking for a working example of running nix inside nix. You know what? We might, if we look in the nix packages collection, actually, might be able to grep in a meaningful way there. So if we would search for any package that has native build inputs followed by nix, something that uses nix at runtime. Do we have anything like that? Sorry, I'll restrict that grep a little bit to packages subdirectory. That doesn't look like an example of what I want. Okay, so I didn't find anything in the standard nix packages collection, so back we go here. This, I would say, does not look very promising. It looks like this looks like they're actually doing the build outside of nix. I think that they use. Okay, maybe we'll compromise for now. We need to ask about what's the status of recursive nix. Can we use nix to build something inside a nix package? But for the moment, a good compromise would actually be to keep doing it the way that we did, but to specifically nominate which package collection we want to query. I think this will do the job pretty well, actually. So it might almost be as simple as that. Let's check. Oh no, we need to do a manual scan now because this object scans itself only once. Ask the nix packages. Oops. Could not run nix env. Debug that. So we got an error. Is that because of the change I just made? failed somehow. Okay, we got. If I poke around in the Smalltalk bugger until I find the root cause, I didn't like the no operation specified. Minus QA query all packages, that is the operation. What's wrong with that? Maybe minus F is the wrong thing. Let's check. Specifies the next expression used by install Debugging. It looks correct to me. So maybe it was just the order of arguments. Could it be something so small as that? Does QA need to go first? Plausible. Let's see. Now if we search for GCC. Sorry, no, we got to do our scan, manual scan again. Get an error again. Okay. Again, I grab the process and ask for its error stream and read that up to the end. What do we get now? Okay, now we get a different error. Getting information about home toolkit studio installer slash. Looks like it's not seeing a space there. That's a bit odd, isn't it not? Try that. Doesn't seem like it should matter. Still get the error. And the next thing on our to-do list was to make the error handling more transparent so that you don't have to navigate around in the Smalltalk debugger to see what errors you got from Nix. It would just pop up with a nice, neatly printed error message. So that's the next thing we want to do. Error getting information about default.nix. Maybe an environment variable thing, maybe. Okay, have a method somewhere for getting path to the version of Nix. Call that instead. See if that helps. So on the UI Smalltalk side, we will resolve that, and then we can actually, because we're in the debugger here, we can just restart from this point and run again. Okay, now it seems to be working. Well, something's going on. It hasn't returned with an error. Maybe that worked. Maybe it reloaded the package collection. Maybe that was the problem. Now if we search for GCC, that looks a bit nicer. Now we don't see this nixos dat. Now we just see the package names. So this is actually the way that we would reference things. If we would search for Raptor, we don't see Raptorjet. I thought we would see Raptorjet there. Okay, but not sure that makes sense. We need to think about that. But if we search for packages or something in the studio, I think we should only see if we are in our right package collection. Yes. So these packages, the studio, those those should only be visible in our own nixpkgs collection, and maybe that that we're not exposing the wrapdigit, like hooking the wrapdigit package up in a way that makes it visible. And you also see that we haven't got these metadata, so I guess I didn't see the value of putting the metadata in when I was hacking that code. But now that we actually have things up and running, it's very interesting to see, you know, if we were debugging and we wanted to manually build the Smalltalk Faro Smalltalk image for Studio, it would be very nice to know that there is a package called Studio Image. Studio Base Image is the one that we download from a known good copy, this kind of thing. So I would say that this is basically working. I think the only thing is, I think we need to this is not completely satisfying because it takes a little bit of time. How long does it take? So let's profile that, shall we? Just to get a feel for how long it takes, and I guess the question is then going to be how long is waiting for the nix process and how long is parsing the JSON output, and I guess we'll be able to see that in the profiler here. So it took about, what have we got, 5 seconds there and 3 seconds there. It's a long time. I wouldn't want to delay starting up the process by that long. I'm also not wild about, you know, taking that hit when. I guess if we would do this asynchronously when the process started, if we would asynchronously load the package collection without getting in anybody's way, that would be pretty okay. I'm not sure if that's an option. Anyway, where were we? More than a second. So by far the nicest thing would be if we could get this done when we build the Smalltalk image, right? So we build the Smalltalk image, it already has preloaded all of the package definitions, and because the build dependencies are tightly tracked, it should also perfectly match the actual package collection. That's the way that we want it to be. The reason that we don't have it that way now is that we don't know how to get a list of all the Nix packages from within a Nix build. This is the recursive Nix problem, so I'm going to have to open an issue with Nix upstream to ask about that. That would be a preferable solution. I'll just for the moment note that in here. And what we might do now, because in Studio I want the Nix packages search to work, which means that we want it to be loaded automatically somehow. And I'm going to say that the least evil way to do that is to just take this hit when we do the search. And you know, I'm a little curious actually, the search engine is running a lot of things, and I think it might even be a little bit asynchronous. So that would be very interesting actually to see. If the search method would take like 5 seconds to run, what would happen from the user experience? You know, would it just take a long time the first time to have the Nix results presented, or would it block the whole UI? Let's find out right now. I don't really know a lot about how concurrency is done in Faro. It might be nice. So we pull up it was the GTSpotter object. We'll do a recursive search, shall we? We'll search inside the GTSpotter. This is actually kind of neat as well. So we did a top level search. Hang on, I don't have it clear in my head. We'll do this slowly, step by step. I close the windows even. Clear our headspace. We open the search engine. We search for GTSpotter, which is a class we're interested in. Here's the name of the class. If we dive in here, we're going to do a recursive search, and essentially the search engine, like the things to find, are going to be implemented by that object. So what does a class object know? What can a class object search on? It can search on instance methods, it can search on super class instance methods, class methods, super class methods, instance variables in a class, references to this class from other methods, all superclasses flattened out, all subclasses, the package it comes from, extensions, examples. So this is actually kind of cool. So in principle, we could do something like this with nix packages. If you wanted to search on a nix package, you might be able to recurse in and search in the definition of the nix expression, the code that builds it. You might be able to search for the maintainer and the other packages maintained by that person and all kinds of stuff. So I'm not suggesting we do that right now, but it's interesting that you can incrementally add as much or as little special understanding of different kinds of data in this user interface. This is the Moldable Tools concept. I think it's a winning concept. I'm very happy that they shared this with the world. Anyway, what were we doing? We were looking for our extension method. We look in the extensions here, and we want to search for a spotter extension method nix packages, which is there, and we could actually hack that right there, I believe. I'm going to open it up anyway. Here. Okay, so we call nix packages default and then get the package list. Just for test purposes, I'm going to make this, when we ask for the default package list, I'm going to make this rescan the package collection every time just to see what the performance impact is like from a user perspective. So if we load up the nix packages class, when we ask for the default, we will make it do a scan every time. So what happens then? If I search now, the search engine has popped up quickly anyway. If I write GCC, it seems to have blocked everything. Not so nice. So we So I mean, the two choices we have here are either to, on the first time we do it, well, at some point we need to load the package collection. I guess a really nice thing to do would be to load it asynchronous. Well, the best thing to do would be to build it, have it already built when we build the Smalltalk image, and for that we need the recursive nix thing. The next best thing to do might be to asynchronously load it when the image starts, so that you don't notice it happening, but it's there when you need it. Next step might be to load it the first time that we do a search like this. And you know, the worst thing is what we've got here, where you reload it every single time. I think we'll try just for right now, because what we want to do is actually the recursive nix thing. So we hope we're going to do something decent and temporary now to keep us out of trouble until we find out if that's viable or not. So we want something simple and reasonably effective. And I think that's going to be that we do the scan the first time. Do the scan the first time we ask for the first time we reference the package definition. So the first time you do a search, it'll wait like 5 seconds, and you'll be annoyed, but that'll only be the first time, each time you start Studio, and then we'll look for a better solution to that. So instead of doing it every time, we'll do it just the first time. And we'll just go in manually and purge out here. So here we have we have an instance variable that's initialized lazily that's already happened. So now we're going to go in and just undo that manually. So we have the nix packages class. So you had a class variable. Called less fancy. Nix packages class. I'll have a method called default. And if I write default here, if I get anything, yes, okay. So we're going to say default is nil. So we're going to manually uninitialize the package collection. Now when we do a search, we think that it's going to be slow because the package collection is not initialized. So we say GCC. Yes, and now it's running slowly because presumably it's off reading in the Nix packages collection. And now if we do that again, we expect it to go fast. Yes. Okay. This is not the end of the world. And I'm curious, one more thing I want to test. If we lower the priority of this, will we see anything beforehand? I just want to check that. So I'm going to flush that out again. So it's going to do the slow one when it loads, and we're going to look just briefly at the GTSpotter extension that we wrote for searching Nix packages. We put it at a pretty high priority. What about if we put it at a lower priority? Would the higher priority things appear visually before this? Let's try. Yeah. So we see a couple of high priority things, and then is it going to pop up with more? Yes. Okay. So that's not so bad actually. So it seems like the spotter sorts all of its search methods into priority order, runs them sequentially, and it shows the results of the early ones immediately, and you can actually use the UI while it's in the background processing those. So that's actually not that bad. So the first time you would do a search, results with a priority of 50 or lower would take a little while while the package collection gets searched. That's actually pretty manageable. So if the recursive Nix thing doesn't pan out, I think that we would be able to live with this quite easily. So that's quite nice. So we're gonna push that off on a pull request. I don't know how interesting it is to live code that. We would like, the next things we want to do on this topic are to see some build progress and to see some errors. I don't want to do that immediately right now. I might either do that in a little while today, or we'll continue with that on Monday. I'm gonna have to think about how I want to fit that work into my my worldview. I'm pretty satisfied with the thing that we did just now. I think being able to search the Nix packages collection from the Studio UI is a significant step forward. So that's cool. So I'm going to hop off the stream right now and either pop back on later today or otherwise another time. So thanks for hanging around. Catch you the next time.